Welcome back. Day 2 of P1 for PreCalc. Now we're looking over basic properties of algebra. Algebra involves the use of letters and other symbols to represent real numbers. A variable is a letter or symbol. For example, x, y, t, theta. That represent an unspecified real number. A constant is a letter or symbol. For example, -2, 0, the square root of 3, or pi. That represents a specific real number. An algebraic expression is a combination of variables and constants involving addition, subtraction, multiplication, division, powers, and roots. Arithmetic operations, addition, subtraction, multiplication, division, subtraction, and division are defined in terms of addition and multiplication here. Excuse me. The subtraction, a minus b, is equal to a plus negative, the opposite of b. Division, a divided by b, is equal to a times 1 over b, where b is not 0. Now, opposite of b is the additive inverse of opposite of b. One over b is the multiplicative inverse, or the reciprocal of b. Let's get that underlined. That's what you're filling in right there, reciprocal of b. Now these properties of algebra you've seen before. Let u, v, and w be real numbers, variables, or algebraic expressions. Commutative property, adding u plus v equals v plus u. Order doesn't matter in addition. Or multiplication for that matter, uv is equal to v times u. Associative property, using parentheses, you associate with different groupings. U plus v, and then add w. Or you'll add u to v plus w. You can multiply the same way. v multiplied together times w, or multiply v and w together and multiply by u. Identity properties where in addition you add 0 and you come up with the same value you started with. U plus 0 equals u. Multiplication property of identity property is when you multiply by 1. The inverse property, when you add and get a 0 for addition, so u plus negative u is equal to 0. The inverse property of multiplication, however, is when you multiply by the inverse of the number we're working with. So u times 1 over u is equal to 1. U cannot be 0, incidentally, in this situation. As we go on to 5, distributive property, u distributes to v and w, or we can have w distribute to u and v. However we'd like to look at it, we use parentheses and multiply those out. Multiplication over subtraction happens the same as multiplication over addition, except we just have a subtract sign in there for distributive property. Now, in the distributive property, which side of the equation is in the factored form? And it should be left. And which side is the expanded form? It's the right, uv plus uw. Now, use the distributive property to write the expanded form. So I want you to expand it out and get x times a and x times 2, so you ax plus 2. And write the factored form of 3y minus by, which with y's in both of them, so you factor out a y, and y equals the quantity 3 minus b. Now these properties of the additive inverse, let u and v and be real numbers, variables, or algebraic expressions. The opposite of negative u equals u. Well, the opposite of negative 3 should be 3. Opposite of u times v is the same as u times the opposite of v, which is the opposite of u times v. Well, this is the same as negative 4 times 3, or 4 times negative 3, or the opposite of 3 times 4, which is still negative 12. Opposite of u times the opposite of v, and the two negatives become positive. Same idea here. The two negatives become positive, and 6 times 7 is 42. Opposite of, the negative 1 times u is equal to negative u. Negative 1 times 5 is equal to negative 5. And the opposite of u plus v is the opposite of u plus the opposite of v. So the opposite of 7 plus 9 is equal to opposite of 7 plus the opposite of 9. And it's still negative 16. We can use exponential notation to shorten products of factors that repeat. So if you remember exponents, I've got 4 of them. This is my base is negative 3, and it's 4 times. So check it, negative 3 to the 4th power is 81. Now, look at this and look at this. a lot of people treat these the same, but they're not. This is actually equal to positive 81 because you have a positive number of negative values. Here you have a negative 81 because it correctly does 3 to the 4th power, which is 81, and takes the opposite according to the order of operations. Please keep that in mind as you're working with this material. Be careful. It can be tricky, and it's all on that basic rules that we have a tendency to rush through. As we go through, do you remember FOIL? 2x plus 1 squared. So we recall our FOIL work, and we got 4x squared, 2x, 2x, and 1, and then we combine like terms. We have 4x squared plus 4x plus 1 is our answer here. Now, exponential notation, let a be a real number, variable, or algebraic expression, and n a positive integer, then a to the nth power, which is a times itself n times, where n is the exponent, a is the base, and a to the n is the nth power of a. Read as a to the nth power. Keep in mind the exponents are used for whatever is immediately to their left. Identify the base and power and answer if possible in each expression. Why don't you guys fill these out, and I'll show the answers in a brief bit. Why don't you just turn off the tape and fill the yours out, and then turn me back on and check my answers. Welcome back. Base, -3, power 6, answers 729. Remember, it's an even number of negatives, so it's going to be positive. And this one, I've got a base of 3, the power is 6, and it's negative 729 because that's a negative value, and I'm going to take the opposite of 3 to the 6th power. Here, this is 2x plus 1 is my base, and 3. Here, I'm not going to have you do the 3rd power of 2x plus 1, at least not at this time. Okay. As we move on, we're going to look at the properties of exponents. Now, keep in mind, these properties of exponents work with the idea of adding our powers because of like bases. So we go m plus n, and so I got 3 to the 4th, 3 to the 5th is 3 to the 9th. When I divide like this, recall that it's the same as, I'm just taking away the number on the bottom, so it's m minus n. So it's 8 minus 6. 8 minus 6 is 5 to the 2nd. U to the 0, anything to the 0 power is 1. And same as except for 0 to the 0 power. We wouldn't do that. It's undefined. And now u to the negative n power is an inverse. This flips it. So it's 1 over u to the n. So 3 minus 7. 3 minus 7 is -4, so it becomes 1 over 4 to the 4th power as we work through here. And now I've got u, power of power property, so I've got u to the m raised to the n power, where I just multiply m and n together. And I got 7 times 6, which is going to give me that 42, so it's 8 to the 42nd power. Here I got uv raised to the m, the quantity uv, I should say raised to the m, the product uv. And I've got u to the m, v to the m, as I am able to raise u to the m power and v to the m power. So this is 3 to the 3rd, x to the 6th, y to the 3rd, as I step through. Here in a quotient, I've got u to the m, v to the m. And so I have 2 to the 4th, 3 to the 4th. And pay attention to this. This becomes tricky. Because here I've got a power, u, raised to the n power, but it's the mth root, and the root's on the bottom. So it's u raised to the nth divided by m. So it'd be 5 raised to the 4th divided by 3, where the cubic root of 5 is raised to the 4th power. Here I got v times u negative n over m power. And I've got the same type here. I've got 5 times 6 raised to the -2 3rd power. Remember that negative in front because of the reciprocal, because it's on the bottom. Now some thoughts. Rewrite radicals as rational exponents, so a become rational, a over b, where b is not equal to 0, and a and b are contained in, that's what that means, contained in z. Don't work with decimals. Rational numbers are easier, so just don't have a bunch of, don't multiply them out. Work with the fractions as we go through. There is usually more than one correct way to solve the problems. Don't skip steps. Okay, just because you start and then you finish doesn't mean ta-da, you're done. Make sure you step through and you can logically show what happened at each step. Simplifying generally means making expressions as small as possible. Combine like terms, dividing out common factors. Always rationalize the denominator. Simplify all radical expressions. Look for perfect squares. Now, let's look at the answers or solutions for 11. First of all, the numbers will multiply numbers. I don't have any powers outside, so I'm going to go 5 times 2, which is 10. And then I've got a to the first, a to the second, which is a to the third, b to the third, and b to the fifth, which is b to the eighth. So I have 10, a to the third, b to the eighth. They get more involved when I have quotients like this. This is 2 minus negative 1, which is, u to the third on top. Negative 2 minus negative 3, which is v to the negative fifth, but it's reciprocal, and that'd be on the bottom. So it would be u to the cubed divided by v to the fifth. Here I've got squared, so let's get this done together and see. I got 4a squared b to the sixth. And then I've got 5a to the 1/2 b to the 5/2, or I could take out, and better yet, take out a 2b and leave a b underneath. And then I can multiply my numbers together, which I get 20, a squared b to the eighth. And then I got a to the 1/2, b to the 1/2. Or I could look at this and combining my a's together with halves. This would be 4 halves, this would be 16 halves. Then I could go 25 halves, b 17 halves. That's my answer. As you step through, just be careful. Some people see things a little differently. Other people will step a little faster, a little slower, but I just want to make sure you know where everything is. In this first one, I'm going to get that fifth power going. So 2 to the fifth is 32 u to the fifth. And I'm going to leave that up there because that's the only one I'm going to do. And there should be a 1 there someplace. There it is. And now I'm going to take and get my v's kind of collected here and u's. So I've got u to the sixth on top and v to the fifth on the bottom. So I've got that collected. Now I'm going to take my square roots. I've got 16 up here. Times 2 is 32, but 2u to the third, so 4u to the third is going to come out. And I've got 2 underneath, and I got v squared because v to the fourth, half of 4 is 2, and 3v on the bottom. And now keep in mind, I've got to rationalize my roots, so I can multiply it by a square root of 3v on both the top and bottom. And that's where I come up with 4u cubed 6v, that's for 3v and 2, multiply together, and 3v times 3v, the square root of, it becomes 3v cubed, should be 3v squared, nope, 3v cubed because it's going to come out, it's going to be 6v squared, and then I got my 3v cubed. And now I don't have a square root in the bottom, and I can finish out and have my 4u cubed 6v to the 1/2 power 3v cubed. So either way, either one of these would be an acceptable final answer. Here I've got 16 3/4 power. Now keep in mind that fourth means the fourth root. Okay, so I'd rewrite this as 16 to the fourth root, which is 2 to the third, which happens to be 8. Here I've got something that's kind of interesting. I'm going to go find an LCD of 12. Okay, x all the way across. So 3 goes into 12x, 4x times. Okay, and 6 goes into 12x, 2x times, or 12. I've got to multiply top and bottom here by 12 because x goes into 12x 12 times. And here I've got 4 goes into 12x, 3 times, so I multiply it top by 3. Now everything is in 12x, and I can combine like terms on top, And after that, I can reduce. And I come up with my final answer. Our last topic is going to be scientific notation. Any positive number can be written in scientific notation, where C, a number between 0 and 10, and I have 10 to the, have a power, or C is between 1 and 10, and M is an integer. Let's look at example 12. Represent the following situations by using scientific notation. The distance between Earth and the Sun is 93 million miles. Well, make this a number between 1 and 10, 9.3. How many places do I need to move that decimal to make it 93 million? 1, 2, 3, 4, 5, 6, 7. So I've got 9.3 times 10 to the 7th. Now, in 12b, the mass of oxygen molecule is about this small. I make 5.3 a number between 1 and 10. And now now when I move to the left, this can be a negative power. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 places to the left. So my final answer is going to be 5.3 times 10 to the negative 23rd in scientific notation. Now in dividing with scientific notation, be smart and use your powers. Here I can look at this and go, well, I can take these three, and I've taken out 1,000. 18 goes into 360 20 times. All right, so now I've got 20 times 4,500,000,000. Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places and 9, but let's talk about it this way. I've got 20 times 4.5 billion. Well, the 2 times 4.5 is 9, but then I'll move over a 0, so I've got 90 billion, and that's 9 times 10 to the 10th. And you can do this a couple other ways. I'm not the only way to go, but this is the answer we're looking for. When I'm looking at things like this, I'm trying to be smart about the use of my values as I go through. I'm going to use my powers. I got -8, so -8 minus -5, which is 5, is got -3, and I got 10 to the 10th, so I've got 10 to the 7th. And I'm going to use my calculator and multiply 2.754, 3.79, and divide by 7.58. So those numbers times 10 to the 7th, and I get those done. It's 1.377 times 10 to the 7th. Now the assignments over the last 2 days, day 1 was on your Schoology, and today's day 2, and that should end our notes. Thanks for listening, folks. If you have any comments about the notes, I know I'm a rookie at this. If I'm going too fast, just remember, stop, rewind, re-listen to it, and if there are some jarbled things, please let me know about it. I hope things are going well, and I hope you're having a great day. Thanks, guys. Have a great day.